So for this week on CyberSchool, we're going to be doing a deep dive into TLS and SRTP. We're doing a major release on our products, adding support to the final products that don't already have this feature set, TLS and SRTP. And I figured this would be a good time to kind of do a deep dive into these two particular features, as it's becoming a lot more common with hosted providers. Providers like Zoom, RingCentral, and others are all supporting and even starting to require TLS and SRTP for any devices on their platform. So I figured this would be a good chance to kind of go through and talk about what these things actually are and how they apply in the VoIP world. So this will be more of a general thing about VoIP instead of, say, something specific to our products. They do, of course, relate to our products because our products support these, but this is going to be more about these particular protocols and how they interact and what they actually do. So what is TLS and SRTP? Most hosted providers are kind of switching over to requiring TLS and SRTP. And since everything is hosted in the cloud and, you know, all of your connections to set up the calls and then all of the audio traffic for those calls is getting sent across the open internet, so it's becoming more and more important to actually encrypt all of that data. So that way everything stays private. So that way you don't have anybody snooping in on your calls or eavesdropping. So what TLS does is it's an encrypted way to actually send the SIP messages. And those are the messages that actually set up the call. So when you pick up your phone and you dial 123 to call the front office, that's sending a SIP message to the server, then to the receiving phone to initiate that call. And with TLS, it's encrypting all of those messages. And specifically what this is, it's an encrypted form of TCP, or Transmission Connection Protocol. And then we've got SRTP, which is just an encrypted form of RTP, which is just how your audio gets sent back and forth between the two different devices. And with these two paired together, it keeps who's called private as well as what is discussed. So that way you've got nothing to worry about if you're using a hosted provider. Nobody's going to be able to snoop and see that you're calling the CEO of another company and you guys are talking about a big merger that's going to be going on that hasn't come out and hit the market that could be huge because they're both IPO companies or something like that. You know, really keeping, you know, who you're calling and what you're talking about private is super important when you're using any hosted providers. And that's in an essence what TLS and SRTP provide. So what is TLS? TLS stands for Transport Layer Security. It's really commonly used across the internet as a whole, encompassed in things, of course, like SIP, but then also things like, say, just your regular web browsing. When you go to a web page and you're using that HTTPS connection, you know, when you look at your address bar and you've got that nice little lock symbol that's sometimes green depending on the browser that you're using, that's using a TLS connection between you and that particular website. It's super commonly used, and the development for it actually started back in 1986, and it was started by a whole bunch of different security agencies in the U.S., mainly the NSA. It was kind of started alongside SSL, which is another form of encryption. We're not really going to be talking about that today because that's not as common anymore. It's kind of used in niche cases, and TLS really kind of built on top of that. TLS was first defined in TLS version 1.0 in RFC 2246 back in 1999. So it took them about 13 years to actually finish the development and standardization of TLS. And over the years, they've done several different versions, version 1.0, version 2.0, and then version 3.0. And of course, with every new revision, they're resolving bugs and big vulnerabilities in there. And as such, the older versions are kind of depreciated and not really used anymore. So with the TLS versions, of course, we have TLS version 1.0 that was released in 1999, and then it was depreciated in 2020, as well as TLS 1.1 that was released in 2006, so about 7 years later, was also depreciated in 2020. And what that depreciation means is that the actual encryption algorithms that TLS takes advantage of to make sure that the data is encrypted during transmission was actually broken. So they're not really safe to use anymore. They don't provide the protection that they were designed to provide. So they were depreciated. They're no longer used anymore. You can still, of course, have some devices that will support these older versions, but it's really not recommended to use them anymore because they're not safe. And a lot of providers, for example, say like with your regular web browsing, say going to Facebook or Google or what have you, will always negotiate version 1.2 or 1.3. TLS 1.2 was released in 2008, and that's still kind of the most commonly used implementation of TLS right now. There is a newer version that came out, TLS 1.3, that was released back in 2018, so it's very, very new, but it's a pretty huge improvement on 1.2. Not to say that 1.2 isn't safe, but 1.3 is just so much safer just because of the huge improvements that they built on it. They added in different cipher suites and then fixed different vulnerabilities that are available in 1.2. Still, 1.2 is still very commonly used. It's still the most common form of TLS that's used out there in the open internet and still really safe to use. And that's what the majority of CyberData devices that support TLS will end up using. So how does TLS actually work? And this is where we're going to get a little heady here as we kind of talk through the path flow just to kind of understand how this whole system works. So for the system, of course, with TLS, it's just encrypted TCP. So everything that we'll be seeing here is just going to be done in a TCP connection. And as we can see here in the first part of our image, our client, the PC, sends a connection request to the server, as we can see here in the first blue arrow that's going over to the right-hand side. And the server responds with an acknowledgement with the blue arrow going back to the left-hand side. And that's the only part of the transmission that's actually unencrypted. Because, of course, for the two devices to say hello to each other, they have to do it in plain text so that way they can both understand each other because they haven't exchanged any keys yet. So then the client does what's called a client hello, where it says, hello, I'm such a client, and I support these different versions of TLS, meaning that I support all these different encryption protocols, what they actually use to, use on their little decoder rings to go and encrypt all the messages. And then the server responds back, picking a particular protocol that they're going to use and exchange a certificate that says, I am this server, and you can verify that I'm this server with this certificate. And then the client will go and verify that certificate just to make sure that the server is who they say they are. And that's done with different certificates that are loaded on the device. There's basically two different types of certificates. You've got the one that's issued that is signed with a private key that you can verify with a public key. And we'll cover that a little bit later. We're getting real heady as we get into this kind of stuff. And then after the client verifies the server, it's possible that the server would also like to verify the client. It's not always required, but it is a possibility. In this example, it does not show that, but that is another additional step that can occur right here. So after they go and they pick a particular cipher or the decoder ring that they want to use to actually encrypt the messages, they send a key back and forth between each other. So that way they can go and make sure that, okay, if I am decoding with this decoder ring, the receiving party, the server, also has to have that same decoder ring to be able to make sense of the information. Once they go and they pick that particular cipher suite, the connection is finished. And then the data can be sent back and forth between the client and the server, between the CyberData device and the VoIP phone system, just so that way all the data can flow through as normal, as expected, and it's all encrypted. And as you can see here, the time, it takes a very, very short amount of time, a little over 200 milliseconds for this connection to occur. And it gets faster and faster as technology improves and as well as network speed improves over the open internet. So this is just kind of a rough estimation of time in terms of how long this connection will take. It's by no means that, every TLS connection takes 200 milliseconds. Sometimes it takes less, sometimes it takes more. But this is kind of in essence how a TLS connection works between a client and a server. And when you're thinking about a client, that's any type of CyberData device or frankly any device that's going to be initiating that TLS connection. And the server is what's going the other part of that connection. And to pull it back to VoIP, the client is always going to be your device, so your CyberData device, and then your server is going to be whatever phone system you're using. So it could be your CyberData intercom registering to Zoom or Ring Central as just a key example. So next we move on to SRTP, or Secure Real-Time Protocol. And this one is paired with another protocol that's known as SRTCP, which is Secure RTP, Secure Real-Time Protocol, Control Protocol. They both kind of go hand in hand. And this was first published back in 2004 with RFC 3711. And this is ideal to VoIP just because there's no impact to QoS, or what's known as quality of service. And the SRTP protocol, which is basically, again, just a way to encrypt the data that's going back and forth between the two devices, the actual audio that's going back and forth, uses what's known as AES, or Advanced Encryption Standard, is just going to be the default cipher. That's pretty standard in terms of encryption algorithms or ciphers that are used for the encryption. AES is very, very common. And they'll use these encryption keys, and they set it up during the initial call setup. So when they're actually passing the media parameters, what different codecs the devices support, will actually be passed during those initial SIP messages. So they don't have to do another TLS negotiation for the SRTP. It's all basically taken care of in the regular call setup process. So now that we know a little bit more about TLS and SRTP, let's talk about encryption, because that's really important to actually understanding it. And there's two different types of encryption out there. We've got what's known as symmetric key algorithms, where both sides, the client and the server, the CyberData device and Zoom, are both going to use the same type of key to encrypt and decrypt the data. This is a very, very simple process. Think your decoder ring that you would get, out of your box of Lucky Charms, where you can both just set the decoder ring to the exact same pattern, and then both sides will be able to decrypt everything. Then you've got what's known as asymmetric key algorithms. And these ones are a little bit more complex, but a little bit more secure, where you've got one key to actually encrypt the message and then a different key to decrypt the message, which are known as public and private keys, which amounts to 4 keys total during a transmission, because one side is going to sign with their private key, and then the recipient is going to decrypt that with the public key. And then when the recipient wants to send the traffic back to the original sender, they encrypt that again with their private key, and then the recipient, the original sender, decrypts with their public key. It gets complicated, but we can kind of explain it. I've got some diagrams that kind of help explain that a little bit. So symmetric encryption is really, really simple. Think about it just like your regular house key or anything like that. You've got a single key, and both parties have the same key. So in our example here, Alice is just trying to let Bob know about his test results. And Alice says, "Dear sir, the results of your exam are, you got an A+, great job." And what she'll do is she'll go and encrypt that with the standard encryption key. And as you can see here in the middle, the message, "Dear sir, the results of your exam, ... have been turned into basically a whole bunch of, garbled gobbledygook. It's no good. You're getting a string of random characters that don't mean anything." But then when Bob receives that, he can decrypt that with the exact same key that Alice used to encrypt it, and then he knows that Alice is just sending him the results of his test. So this is the simplest form of encryption that you can use, where both parties are going to be using the exact same key, very, very basic encryption. Kind of like, when you were passing notes in grade school and you came up with your own little, language to pass notes in between your elementary school sweetheart. It's that same type of deal where you're using that exact same key, very, very basic encryption. And this is how SRTP is actually encrypted. Both parties are going to be using the same key, because with SRTP, since it's audio, it needs to be as fast as possible, and they don't have the time to deal with the complication of multiple keys, which can add a little bit of a delay there. So symmetric encryption is best for speed, and since RTP, the audio, is dependent on speed, that's going to use symmetric encryption. Next, we move to asymmetric encryption, where each side, both Alice and Bob, have 2 different keys. So in this example here, we can see that Alice is trying to send Bob some data. What they're sending doesn't really matter. It can be that same email message that we were looking at before, just giving Bob his test results. So what Alice will do is, to make sure that that traffic is protected as she sends it over there, she'll sign it with Bob's public key. And now that data is encrypted and can only be decrypted with Bob's private key. Anybody that goes and tries to decrypt it with Bob's public key, it's not going to do anything. It's just going to still end up being garbled. It's not going to make any sense. So Bob will go and unsign it with his private key. He'll unencrypt it, and then he'll be able to read that the test results that he got from Alice. And if it works it works exactly the same in the other direction. So if Bob wants to go and contest his grade, he got an A- instead of an A+, he wants to go and kind of circle back to Alice, what's going on, and want some extra credit, what have you. He'll send the message back to Alice and do the same process that Alice did. She'll sign the key. Bob will sign the message with Alice's public key, and then Alice can decrypt that message with her private key. So both sides are going to use two keys, Bob's public key and Bob's private key, and Alice's public and Alice's private key. So there's 4 keys in play total. The public key is shared, and they're typically shared on what's known as a public key exchange. There's literally websites that you can go to download different people's public keys. And then the private key is private. It's supposed to be shared. It's supposed to be private. You're not supposed to share it with anybody. Typically, like most real security experts will store their private key on, say, like a USB flash drive or something and keep that off their main device. They really keep that thing private because it's a private key. It's supposed to be used as such. So data is, of course, encrypted with the public key, which then allows it only to be decrypted with the private key. So that way it's a little bit more encrypted. It's a little bit more careful. A key example of something that you can think about, like it would be, say, like a P.O. box at a post office, or if anybody's ever lived in an apartment complex where you've got the big shared communal post office boxes, where the post office worker can come in and when they're delivering everybody's mail, they've got one key that will go and unlock the entire panel where they can go and just give everybody mail. But then you've got your private key, which only opens your box. It's kind of the same exact deal if you're thinking about that type of scenario. There's 2 keys in play, one key that opens all the locks, and then you've got another key that only opens one lock. It's a little bit more complicated than that, but it's pretty easy to think about that in a high-level 1,000-foot view. Again, 4 keys in play: Bob's public and private key, and Alice's public and private key. So now, what CyberData devices actually support this? Now that we kind of know what this thing does, how to use it, so just about all new CyberData devices support TLS and SRTP. The TLS versions that we support are version 1.0 through 1.2. So we do support both the depreciated versions of 1.0 and 1.2, or 1.1, excuse me. But those aren't enabled by default. You have to opt into using those. And by default, if you opt to use TLS, it's going to default to version 1.2. So that way you're protected as you send your data out there. If for some reason you need to use one of the older depreciated versions, say you've got an older phone system that does support TLS, but only say TLS version 1.1, you can still use your CyberData devices on there. And then for SRTP, there's a different kind of way that you implement that. With TLS, you're always just going to be using TLS. With SRTP, you've got options. You can either set it to off, where none of your audio is encrypted. You've got optional, so that way if the parties support say the person that you're calling, you press the intercom and it's calling a ring group, and somebody's got an older phone, it doesn't support SRTP, and the rest of the users all have newer phones that do support SRTP. If you set it to optional, if both parties support SRTP, they'll use SRTP, but you'll also be able to call people that don't support SRTP. So that way you can still basically have a conversation with everybody. But if you're more concerned about SRTP and you really want to make sure all of your data is encrypted, really recommended you set it to mandatory. So that way the devices can only interact with other devices that also support SRTP. And you can use the optional and mandatory together, because if a device supports SRTP, they'll work with devices that are set to optional because they support SRTP, but they'll also allow for communication without SRTP. So mandatory is usually the best way to go, but if you're not sure about the parties that you'll be calling, optional is great because you'll use it if you can and not use it if you can't. So TLS, when you're setting it up, the data is always encrypted. So if you set it to TLS, you don't have to worry about it. There's no optional or mandatory or anything like that. If you opt in to use TLS for SIP, it's always going to be encrypted, no matter what. That's just the way that it's designed. So at the end of the day, should you use TLS and SRTP? Absolutely. If your equipment and your server actually supports it, definitely use it because you're just protecting that data that you're sending across the network. So that way, if somebody's out there and they're trying to sniff on your traffic, they know that you're calling CEOs, they heard some news that your company might be getting bought out and it really could drive up stock prices. You might have people that are trying to sniff your phone calls and trying to find out those good details on when the merger is going to occur and when you're going to go public with it. So if your equipment, your server supports TLS and SRTP, absolutely use it. More protection is always better. You've got a lock on your front door, so you might as well use it. It's really common with hosted providers and becoming more and more common. I think the whole thing with the pandemic and everybody getting stuck at home and working from home has really prompted a lot more providers to push forward their efforts to actually add support for TLS and SRTP. It's always been the way that the market's been going, but since the pandemic and more people have been driven to using hosted providers, RingCentral and Zoom in particular have really blossomed in this last year. They've really done a ton of business. They're really pushing to add support for TLS and SRTP and have that as a requirement just to make sure that their users are really protected as they work from home. It's really supported by a lot of providers in general. It's becoming more and more common as the days go by. We're literally getting more and more people all the time to go and add support for this different protocols. So it's definitely going to be up and coming and more popular. There's no impact on quality or speed, so you're really not losing anything by opting to use either of these protocols. And at the end of the day, it's really good to just protect your data. So for definitions here, I usually like to go over different terms and stuff that we used as we went through. TLS, or Transport Layer Security, that's going to be the main protocol that actually gets the SIP messages from end to end and does that encrypted. We've got SRTP, which is just secure real-time protocol, and that protects the actual voice traffic that's going between the two parties. And TLS and SRTP combined make sure that the setup calls and what you're talking about are completely encrypted. SRTCP basically just sets up the ports and everything that are used for RTP. Not super important for today's discussion, but it's definitely very useful, and that's just secure RTP, secure real-time protocol, control protocol. Then we've got QoS, which is just quality of service, which is just the delivery speed and how good the audio sounds. Very common to run into, and thankfully TLS and SRTP don't impact QoS. And then finally, we've got AES, which is the Advanced Encryption Standard, which goes and actually protects the different, and it's the main different cipher suites that will be used with both TLS and SRTP.
Thank you for watching this edition of CyberSchool. If you have any questions, please get in contact with our sales department. They are available by email at sales@cyberdata.net or by phone at 831-373-2601 extension 334. Please make sure to like this video and subscribe for more content like this from CyberData.